We're going to finally get into calculus. So we're going to talk about derivatives and rates of change. Yeek, yeah. So one of the big ideas in calculus, and something we discussed when we first started to discuss limits, was this idea of a slope of a tangent line at a point. Remember that? And the problem with finding a line at a point is that you need two points, right? That's the issue. And so you want an equation of line at P, which we're going to say has points, coordinates A, f of A. And then the problem is that you need 2 points, and so what do? And so the basic idea is you pick a nearby point, and their book calls it Q, and that point has coordinates x, f of x. And this is called a secant line. And as x goes to A, your estimate of m gets closer to the tangent line slope. Yep. Let you catch up writing, then we'll talk about where that slope equation comes from. Okay. So in this picture, what are P's coordinates? They were given in the box above. They were the x is A and the y is f of A. And Q is just some other point, and that's going to have coordinates x, f of x. Okay, from this picture, it's pretty obvious that that particular estimate that's drawn is a pretty crappy estimation of the tangent line slope, right? But can you see what they're trying to get at, that as this Q goes closer and closer to that point P, the slopes are kind of converging to the right thing? Okay. So where does this equation come from? The f of x minus f of a over x minus a. It's y2 minus y1 over x2 minus x1. And so this point is the second point. So if you do y2 minus y1 over x2 minus x1, that's f of x minus f of a over x minus a, and that's going to be about equal to the m, where m is the slope of your tangent line. It's going to be an estimate or an approximation, and it'll get better and better and better as those points get close together, which means their x coordinates get closer together, right? And so to make this equal m exactly, they say, okay, I take a limit as x goes to a, and that's what happens as x gets as close as possible as it can to a, which means that those 2 points are getting really, really close together. Okay? So, but the basic general idea is that you have a slope, and now the other thing to remember is that f of x is the function itself. F of a is the function with that particular a value plugged in. Does that make sense? So x and f of x and x are a point that's changing, but a and f of a are points that are fixed. So let's do this with one specific point. So find an equation of the tangent line to this curve at the point 2, 4. Okay. So the slope will equal limit x goes to a, f of x minus f of a over x minus a. we have a parabola. And we're trying to find the equation of the tangent line at that point. So what is the a value in this example? The a value is 2, because a is the x. Okay, what is f of a? 4. 2 squared or 4. Okay, so ends will be limit x goes to 2. F of x is just x squared. F of a is 4 over x minus 2. Does that look slightly familiar-ish?
So the f of a is whatever the function is.
The f of a is the y value of that function at that point. Yep, so if a had been 3...
Or a cube, I meant.
Yeah, if it would have been a cubed, yes, then you would have had x cubed minus 8. Does that make sense? So it's function minus the... I mean, you've got what you have is you have this point. The x coordinate is 2. The y coordinate is 4, right? 4 is f of a, 2 is just a. Okay, so now this is the slope of any secant line no matter how close x was. So you could pick x to be 2.1, 2.01, stuff like that. But can you figure out limits like this since you know how to find limits now? Yeah, so how do you start this one? Factor, factors into x plus 2, x minus 2 over x minus 2. So that's the limit as x goes to 2 of x plus 2. So what's that going to be? 4. So the slope is 4. M equals 4. Okay, and then find the equation of that tangent. And does it seem plausible that that slope has that slope is positive? The pictures in the picture? Yeah.
Yeah.
Okay. Now the equation of a tangent line, use the equation of a line, y minus y1 equals mx minus x1. What do you input for x1 and y1? The point, yep, 2 and 4. So what goes in for y1? 4. What goes in for m? 4. X minus 2. And let's just get it in slope-intercept form because, so 4x minus 8, or y equals 4x minus 4. Okay. Alrighty. And this tells you like how fast the function is increasing at that point, like its rate of change, the speed of the function. It's increasing more quickly there than it is like down there, right? How quickly it's climbing, kind of. It goes faster and faster and faster and faster. Okay. So most calculus books start with this definition because this definition is more obviously explained by the slope. Does that make sense? Like it's y2 minus y1 over x2 minus x1, right? Here's another, this is the one we're going to use almost all the time. Does the f of a plus h minus f of a thing look awfully familiar? Yeah, right, I did that to you a bunch of times, didn't I? I like made you, yeah, okay, here's why. Because instead of picking two separate points, so you have your curve, you have your point A, so your point A, f of A, you say h is a small number, i.e. close to 0. So then your nearby point, you could think of as a plus h is the x coordinate. It could either go above or below. If h is positive, a plus h is a little bit above a. If h is negative, a plus h is a little bit below a. So then that point has coordinates x is a plus h. What is the y? F of a plus h. So what would an estimate of m be using those specific values and taking the top one to be y2? So it'd be f of a plus h minus f of a, the other y, right, over what's in the denominator? Uh-huh. Okay, you see that? So it is really the same thing, right? It's y2 minus y1 over x2 minus x1, but what happens to those a's? They cancel. So an approximation we have for m is f of a plus h minus f of a over h. And the way you get m exactly is you limit h to 0. And if you take h to 0, that has the same effect of saying a and a plus h go close together. Does that make sense? If h gets small, this point's going to get close to that point, right? Yeah. And it turns out that finding the slopes of tangent lines is often easier with this. The algebra is more straightforward, whereas with the previous one, the algebra can be tricky, like it involves tricky factorizations and stuff like that. So this is the one we're going to use most of the time, but it really is, it is also slope. It's just the fact that those, because of how you chose your h to be close to 0, the a's end up canceling. It doesn't look like slope as much as the previous one does it? Okay. So if I ask you to find slope of tangent line, you say, okay, I use this limit formula. Okay. And everything today is going to like use that thing, so by the end of today, you have to have that memorized. I would suggest writing down the definition every single time you do a problem, because you're not going to have any choice but to remember it then. Like 10 years from now, you don't want to. Okay, find the equation of the tangent line to this at the point. I don't know why I wrote points. At the point. I really can English most days. At the point 1, 2. I just used a noun as a verb, though, so maybe I really can't English. Okay, so the slope is the limit as h goes to 0, f of a plus h minus f of a all over h. So what is a equal to for this example? 1. Good. So this will be limit h goes to 0, f of 1 plus h minus f of 1 over h. Is that okay? All right. What is f of 1 plus h going to be? 2 over 1 plus h. Very good. Yep. Because you plug 1 plus h into f, right? And since, I mean, I didn't write it as f, I wrote it as y, but it's the same thing, right? Do you buy that? What is f of 1 going to be? 2. Came from doing 2 over 1, right? And then all that business over h. Okay? And so really, other than the fact that you've got to set the limit up yourself, the rest of the stuff isn't that different what we just did, right? Okay. So how did we deal with the whole over he business? Because fractions within fractions are just nasty and ugly, and that's bad math grammar. You shouldn't do that. How do you get rid of this? Division by h is the same as multiplication by reciprocal, which is 1 over h, right? The technical reason is you multiply by 1 over h there, 1 over h there. In the denominator, the major denominator, the h's cancel, giving you limit h goes to 0. I'm just going to write that 1 over h in front. 2 over 1 plus h minus 2 over 1. I'm going to leave some space there on purpose. When you see two fractions, what's your strategy for going? So what do you multiply that second fraction by? 1 plus h over 1 plus h. So that's limit h goes to 0, 1 over h, 2 over 1 plus h. That negative distributes, so you've got minus 2 minus 2h all over 1 plus h. Okay, so what happens when you add the numerators together? What's left? Mm-hmm. Over 1 plus h, and then can you cancel that problematic h from the 1 over h? Yes, awesome. So limit h goes to 0, negative 2 over 1 plus h, so holy bejesus, you're done, and the limit is equal to? Yay! Everybody should like start talking loudly so that this can be more fun. I'm tired of waiting for you to answer. You need to answer quickly. Maybe you can't process. I should stop being impatient. Okay. So the slope is negative 2. Great. Be very, very careful that you follow instructions out all the way. So some questions will ask you to find just the slope, and some questions will ask you to find the equation of the tangent line. Okay. This one you only have m. Did the question ask for just the slope or the equation? The equation. So y minus y1 equals mx minus x1. So that's what? Y minus 2, right? Equals negative 2x minus 1. So y minus 2 equals negative 2x plus 2. I think that's y equals negative 2x plus 4. Do you guys agree? The second part isn't very hard. The most common thing I see like on a quiz when I ask you a question, I'm going to ask you to find both the slope and the equation, is that people just forget to do the second part and then they get it wrong because they didn't do it, not because they don't know how, and that's really a bummer. So, you know, read instructions. Okay. So this slope has a special name. It is called the derivative, as in the slope of the tangent line. And that's the derivative at a specific point, but that's what it's called. And roughly speaking, you can think about it as how quickly the function is increasing, decreasing, or changing at that point. So we're going to talk about some applications. And one common application is particle physics. So here we go. Suppose an object moves along a straight line according to some equation of motion, s equals f of t. So s is the displacement, and that's the directed distance. So you have, like, number line, you've got the origin, and you have this particle that's going, like, back and forth, like bopping around. Maybe it goes forwards and then goes backwards forever. But it does some kind of forwards-backwards thing. And the directed displacement, meaning directed distance, means how much forwards, how much back from that 0 point. Okay, so how would you find the instantaneous velocity? And so think about what would be, as I always think about, like, say, driving. I find my average velocity by taking my change in position divided by my change in time, right? So here you're going to do, I'm going to say delta s over delta t. i.e. change in position over change in time. Okay. And so that would be, well, suppose you had time t equals a, and another time t2 we'll say equals a plus h, where h is some little bitty number. Your change in position is f of a plus h minus f of a divided by change in time, a plus h minus a. And you could think, okay, t equals a is, 1 hour, a plus h is 2 hours, or 1 hour more. But do you see that it's the exact same formula? Okay, so, and that's the idea. And oh, by the way, what would this units be? Suppose that S had units, say, meters, and T had units, seconds. Oh my gosh, my eraser is huge. S in meters, T in seconds. This would have been meters per second. And this officially, the whole f of a plus h minus f of a over h is an approximation. How do you get it exactly? Take the limit as h goes to 0. And h being how much time past the time t equals a that you are looking at.
If it's in feet per second, you're just doing it wrong.
It does happen though, so yeah, if you're in feet per second, your physics people will get mad at you, but some of the questions here definitely do end up in feet per second. So yeah, I mean, I should switch, but we just happen, so it's just not going to happen.
I mean, if Britain switched, we can switch.
Yeah, well, we're going to discuss math, not other things. Okay, so I have some ball, and the ball is thrown in the air with some kind of initial velocity of 40 feet per second, and its height in feet after t seconds is given by this equation. So what happens is that ball goes up and goes back down, right? And it goes straight up and straight down, and this is just like what happens over time as time passes. And so this is a graph of at what time, what is its height, okay? Okay, I want to find the velocity when t equals a, and then use this to find the velocity at two specific values. So what I mean by this is that instead of plugging in a equals 1 and a equals 2 and doing two limits separately, I'm going to just plug in a and work out what that limit is, and then at the end when I'm done, use that formula. So here's what I mean. So the slope will equal the limit as h goes to 0, f of a plus h minus f of a all over h. I'm just not going to plug in a specific a value. I'm just going to plug in a variable instead. Okay. So if you took that equation and you plugged in a plus h, what do you get? Great. Yep, exactly. So that's plugging in a plus h minus, what do you get when you plug in a? And if you forget this thing, you're going to get messed up. So what do I need to have there? To say I'm taking away all of f of a, parentheses, exactly. That is always the answer when I ask that question. I'm not very creative, but it really is the case. If your expression you're taking away has more than one term, you need parentheses. And if you get messed up and stuff ain't canceling, it probably is a parenthetical error. Okay, over h. And then it's just like algebra city. So you never knew that algebra was a city, did you? I was trying to make a joke. It's a place you can go. Just kidding. Okay, so 40a plus 40h minus 16 times, what is a plus h quantity squared?
A squared plus ah plus h squared.
A squared plus 2ah. Yep, no, it's okay. Plus h squared. And then minus 40a plus 16a squared, because that negative distributes. And I might be wrong, but if you look at just like the second line, that's a question I could have given you just as like find a limit, right? Do you see what I mean? Okay, what cancels?
40a and the 16a squared.
Very good. Yep, the 40a and the 16a squared cancel. So 40h is still left. We're going to have minus 32ah minus 16h squared over h. And you got to see if you agree with that, because I make mistakes, so, but I think that's everything. I'll just draw little dots above who canceled. This guy and this guy canceled, right? And then once you distribute, this term will cancel that term, right? Don't forget that the negative also goes to the 2AH and the H squared, okay? Now can that H be canceled? Woohoo, and that should always happen. If it doesn't happen, you did something incorrectly. Okay, so like this will always work. 40 minus 32A minus 16H. So what does that equal? Yep. Okay. So this tells you the slope for any A. So at A equals 1, or T equals 1, how would you find the slope? Plug 1 in. 40 minus 32, it will be 8. And if you have a problem that comes from a context, let's give it units. I'm pretty sure this one's going to be in feet per second. It's kind of my fault for not labeling it correctly, but notice that the question says that the initial velocity was 40 feet per second. So same units here. How about at A equals 2? What's the slope there? And that's negative 24, right? What does the negative in that tell you? The ball is going down, exactly. It's on the downward part of that curve. You've got to be a little bit careful to not plug numbers in outside those values, because your ball actually, you wouldn't plug in negative t's. Does that make sense? There's also an ending t when the ball hits the ground, and you don't want to plug in values past that because your ball's on the ground and it's not going down anymore. Okay, but isn't it kind of cool? I mean, I think it's definitely nicer in some sense to have a formula, and then you can plug lots of values in, as opposed to like doing the same process repeatedly for different values of A. Does that make sense? Okay. So this thing comes up so often, it has a name. It's called the derivative. So, and the notation, one notation is this, it's F with a little apostrophe, and it's read F prime. I'm just going to say F prime without realizing that I'm doing it because I've done this so much, okay? But that's what F prime of A. And so F prime of A is the slope of the tangent line at x equals A.
Could you start calling F optimus?
To f of x, that is. Say that again?
Could we start calling F optimus?
It is the optimus prime?
Yeah, get it?
Is I don't actually know what that means, but...
Optimus prime is the Transformers thing.
Oh, okay, yes, okay, well. I just know Doctor Who jokes, guys, that's all I got. Okay. Dr. Prime, okay, that's not cool. Okay. So find the derivative of this, and then find an equation of the tangent line to the function at the point 1, 2. So how I'm going to do this here is I'm going to find that formula, f prime of A, and then I'm going to plug A in at the end. And personally, this is my preferred way to do all these problems. I like to get the formula first and then just plug the numbers in once I've gotten it. I just find it easier. So you can do it the way we did in the first examples by using like the specific numbers like 1 plus h or 2 plus h, or you can just use a plus h and then plug A in when you've got the formula. I think it's easier, but that's just me. Okay, limit h goes to 0, f of A plus h minus f of A all over h, right? H goes to 0, not 6. 6. Okay, so what is f of A plus h? Great, yep. And then minus.
5 minus 2a minus 6.
What did I forget? Okay, good. All over h. Okay, how about you start working it out? It's just algebra now. Expand, simplify. I'll write my steps pretty neatly. Be very careful with parentheses. And you could say equals f prime of a, I guess, right? Okay. Say that again, yeah? So does an x equal 1? 2? What was the number the x was? Say that again?
Oh, no, I was wondering, doesn't it equal m?
Or m, yep. But the thing is that m is not quite as informative. So the way that they say m, because the thing is m is a slope of any line, but this tells you what function it's related to. It's related to that f function. Okay, so everybody get -2 minus 2a? Okay, so how would you find the equation specifically at the point 1, 2? Oh, and by the way, what do you think? I think the trickiest part in this question is that right there, you see my little red pointer? If you forget those parentheses, you're going to mess up the signs. Does that make sense? So just be really careful when stuff expands into having more than one term. If it's preceded by a negative sign, you've got to be careful with parentheses. Okay, so equation at 1, 2. What is the slope going to be? How would you find it? What would you plug in?
1.
F prime of 1. So that's -2 minus 2 or -4, right? All right, then the equation is y minus y1 equals m, x minus x1. So y minus 2 equals -4 x minus 1. Or y equals -4x plus 6, I believe.
Yeah.
I did math in my head, so it's never a guarantee. There's arithmetic in my head. Okay, you all right with that? By the way, if you, yes?
Let's see now. So I kind of saw it in example 3, but in this example, so you end up with -2 minus 2a, and that's just the bits for a. What do you do with that minus h? Like you just kind of floats off and then
There's limiting as h goes to 0. So you plug in 0 for h.
Oh, plug in 0, okay.
Yep.
All right.
Yeah, no problem. You good? Okay. only sucky thing about this is that the algebra can get kind of tedious. Like the next one has tedious algebra, and by the way, if you know shortcuts, you can't use them yet. I know. Okay, you can be angry at me for like today and tomorrow, and then we'll learn shortcuts on Friday. To do 1 day of suffering through shortcuts. You can do your web assignment with shortcuts because I can't tell how you did it. But if you don't know shortcuts, I'm sorry. You can YouTube them. You want to learn them for Friday. Okay, so given this one, find f prime of a. So just f prime of a, we're not going to actually find a tangent line for a specific thing. So that'll be limit h goes to 0, f of a plus h minus f of a all over h. So what's f of a plus h going to be?
A plus h squared.
Uh-huh.
Plus 2 over a plus
Plus 2 over a plus
h.
h. And then minus parenthesis a squared plus 2 over a. All that jazz over h. And I really hate fractions within fractions. I'm going to make that 1 over h times stuff because, like, ugh. Okay. So then a plus h squared is a squared plus, plus h squared. Good. Plus 2 over a plus h minus a squared minus 2 over a. Okay. And unfortunately not a lot cancels. What cancels? The a squareds. Okay, so I've got limit, I don't know why I just wrote 1 over something. And eraser, we're going to make you smaller because you're annoying. Okay, we've got, oh no, limit h goes to 0, 1 over h, 2ah plus h squared plus 2 over a plus h minus 2 over a. Okay. So I kind of like to do stuff like based on what your first instinct is because I think that would means you're going to be able to generalize it more, but there definitely is an easier way to do this. Do you see how if that 1 over h distributes, some h's will cancel? So will the h in the first part cancel? How about the second one? I think if you do 1 over h times h, we're just going to get h, and that's okay, right? So I'm going to distribute the 1 over h, because I think it will be easier. So it's 2a plus h plus 2 over h times a plus h minus 2 over a times h. And I'm going to leave some space there because I'm going to get a common denominator. Does it make sense what I did, though? Okay. If you plug in 0, is this 2a going to give you problems? No, so leave it alone. If you plug in 0 here, is that h giving you problems?
No.
No. It's these two that are the issue, right? So technically speaking, what you could do is you could actually limit this first piece and the second piece already. That first piece, there's no h to plug in, so it's just 2a. The second part is 0. And then we're going to find the limit h goes to 0 of this part and that part. Because in those two pieces, the h being 0 is a problem because you make 0 in the denominator. And I swear we're almost done with this. 2 more steps. So now in that second piece, what are you going to do with it? So this would be a over a and a plus h over a plus h, right? To a plus limit h goes to 0, 2a minus 2a minus 2h over h a plus h. Okay, so that's going to be 2a plus limit h goes to 0. Okay, what happens first? What cancels first? 2a's. And then, once they're gone, h can cancel, right? And you'll have negative 2 over a times a plus h. So finally, you can say, okay, this is 2a minus 2 over a squared. Do you understand why the bottom is a squared? Okay. Because h gets to go to 0, and a times a is a squared. Whew, man. Alrighty, you okay with that? It's just tedious, right? Like, it's just tedious algebra. It wouldn't have been wrong to get a common denominator at this step across the entire fraction. That would have also worked. It's just going to be more tedious. Does that make sense? So that would have also been fine. Multiply, the first one by a and a plus h, the second one by the same thing, and that would have been just fine. It would have worked, okay? So it's not going to be incorrect. Alrighty. So this one's just a little bit more physics, and I'm only going to start part B because I think you'll know how to do it, but I want to just make sure we review how do you find an average velocity over a time interval. Just what would you do? So between 4 and 8, how would you find the average velocity?
Just get the slope between the 2 points?
Mm-hmm. So plug in 8, that's the y2, right? Minus plugging in 4 over 8 minus 4. And we'll just do this one. We'll skip double I. So that'd be 1/2 times 8 squared minus 6 times 8 plus 23 minus 1/2 times 4 squared minus 6 times 4 plus 23 all over 4. So that's what it means with average velocity. It could also ask for a secant lines for the same thing. Okay, so this is what? 64 halved is minus 24. No, 8 times 6 isn't 24. It's 48. I don't know what I was thinking. Plus 23. And then minus parenthesis, that's going to be, I think, 8 minus 24 plus 23. And if I give you no calculator, being clever is a good thing. By which I mean, is it clear the 23s can cancel out? I didn't distribute the negative yet. But once the negative distributes, this 23 will cancel with that 23, right? And we'll have 32 minus 48, which is negative 16. Do you guys agree with that? And then minus 8 plus 24, all over 4. Oh my gosh, is this 0? Is it 0? I think it is. 0. What are its units? So you can think it came from y over x, right?
So 0 feet per second?
Feet per second. So what does that mean happened to this particle? Doesn't seem right. Okay. Well, if I went from my house to Nenana and back, and it's a directed distance, how much has my position changed from the original? None. Does that make sense? What this means is that the particle went from one place back to, it has some stuff that canceled itself out. Okay, so that's the kind of the idea. It's kind of like, you could say the particle it go up and down. If you found the slope with those 2 points, you're going to get the slope of 0, right? This would be a terrible estimate of what the slope was at 4, for example, right? Because 4 and 8 aren't very close together. Or a terrible estimate at 8. This would be a much better estimate of what was occurring at 8, right? But yeah, 0 is a possibility. It just means that there's been no change in position. You could have gone forwards and gone back. You return to start. Okay. How would you find the instantaneous velocity? Just tell me how you start. I would first find the s prime of a. Does that make sense? Because asking for the instantaneous velocity when t equals 8 is the same thing as saying what is this derivative thing at 8, or what is the slope at 8. So find s prime of a using the whole limit thing. Limit h goes to 0. It'll be s of a plus h minus s of a over h. S instead of f, but who cares? It's just a different letter. Nothing's really changed. Just tell me what you get when you plug in that stuff, and I'll tell you what the answer is going to be. So limit h goes to 0, 1/2 times a plus h squared, right? Minus 6 times plus, great, minus, great. And this is just tedious now, right? I mean, like, you could work that out, but you get the idea. It's like blah, 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 step, step, step. You end up with a minus 6, okay? And if you want to test yourself and see if you can do that, do all the algebra, work it out, you should get a minus 6 in the end. Okay, so at t equals 8, s prime of 8 is equal to 8 minus 6, or 2. And what are its units? Feet per second. So at that time, is the particle going forwards or backwards? Forwards. Or if it's going up or down, it'd be going up, right? It just depends on which way you define to be the positive direction. Positive is either up or forwards. Okay. Man. Alrighty. So the thing is, the point is that the question, when it asks for instantaneous velocity, it's the same thing as it's asking for slope. Nothing different. It's just slope with context. That's all. Okay. And then just some about what these things mean. So suppose you have a gold mine. I thought this question was very applicable to Alaska because we have gold mines here. So, and the cost of producing X ounces of gold is given by this equation, C equals F of X dollars. So what is the meaning of the derivative, and what are its units? Once again, I did bad English, but you know. I personally, the book always asks these questions in this order, which is why I do as well. I think that figuring out the units first helps you figure out the meaning. Okay, so this comes from change in y over change in x. In this case, it's change in c over change in x, because c is the same thing as y in this context, right? So what are y's units? Dollars, because y is the cost. And then over the units of x, which is ounces. So the units are dollars per ounce. If you were, like, suppose you're not panning for gold and you're actually like dredging for gold, and you buy all this crazy super expensive equipment, the cost of your first ounce is like ridiculous, right? Because you had to put up all the money for that equipment, right? What happens over time to that cost per ounce? Probably goes down, right? Assuming you find gold, right? Okay, so what is the meaning of the derivative is it's how the cost is changing. Does that make sense? Or it's the rate of change of the cost. I guess you could say relative to number of ounces. I want to say produced, because you don't produce gold, you find it, right? Found. Does that make sense? Okay. If the rate of change is positive, are your costs increasing or decreasing? Increasing. If your rate of change is negative, the costs are decreasing. Okay, so what does the statement f prime of 800 equals 17 mean? Okay, so this is like the x, right? So that means you're producing how much gold? Mm-hmm. So when you produce 800 ounces of gold, the cost is doing what? Going up or going down? Increasing. At $17 per ounce. Maybe you started off by panning gold, you discovered, oh no, this is not going to work and I have to buy something. I mean, that could be something that happened, and so therefore your cost is going up because you're like making payments or something. Okay, so do you think that the value of f prime will increase or decrease in the short term? What about the long term? So this, you could argue lots of different things. So personally, I think that in the short term, f prime of x will decrease as your initial expenditures are spread out. Does that make sense? Assuming you put forth all this money into the beginning, right? And then, okay, well then you find some gold and you start to like pay for itself. So the cost per ounce is going down because you're not putting any more money in. But what about over the long term? Yeah, I think f prime of x will go up as the quote-unquote easy stuff is found. And this definitely has been true for oil, right? Like initially the expenditures per, say, barrel went down, right? But then once they found all the easy oil, stuff like the Arctic, which is complicated and messy and tricky, right? The expenditures per barrel go up, or like the tar sands in Canada, right? They were not viable for a long time, and they're not viable now because the price of oil is so low. So, okay. Now, it could be the case that instead of being given a function, you're given a table. So this shows the world average daily oil consumption. Oh, look, that was not intentional. Measured in thousands of barrels per day. Okay. So compute and interpret the average rate of change from 1990 to 2005. What are the units? Okay, so first of all, which row corresponds to 1990? This one. Yep, the second one. Which one corresponds to 2005? I think 20. Do you agree, though? Yeah. Okay. So the average rate of change just means take the difference in the y's over difference in the x's. So this is 84077 minus 66533 over 20 minus 5. And I forgot my calculator, and I didn't write this down, so could you guys tell me what that is? Say it again, 17?
17,544.
544 over 15, and approximately that's
1170.
okay. Okay, and its units are kind of complicated. It's thousands barrels per day per year. Does that make sense? It's y is units over x is units, and that ends up being per. So is oil consumption, is average daily oil consumption increasing or decreasing? Between those years, it is increasing. Okay. Estimate the instantaneous rate of change in 2000 by taking the average of two rates of change, and they leave it to you to pick them, but pick the two best ones. So 2000, first of all, is which part of the table? 15. This is 2000. So if you were going to get the best estimate for the slope at that point, I would use the two closest points, by which I mean 10 and 15 and 15 and 20. Does that make sense? Okay. So using 10 and 15, our estimate is 767,844 minus 70099 over 15 minus 10. Say that again? I added an extra 4. Okay, thank you. Get rid of it. Okay, that ends up being about
6685 per 10.
over 5.
Oh, yeah.
I got 1,337. Did you get the same thing?
Yep.
Okay, great. And how about with 15 and 20? What two numbers get subtracted in the numerator?
84074
Mm-hmm. Over 5 again. Yep, over 20 minus 15. And I got that's about equal to 1,458.6, so 1,459. And so your average is just take those two and divide it by 2. Add them and divide by 2. 1,337 plus 1,459 over 2, which I got is about, someone give me a...
1398.
Okay, thank you. And then thousands barrels per day per year. I don't know how picky WebAssign is about like how much tolerance it has for rounding errors. I would suggest giving this number and this number more decimals so that your average is more accurate. Does that make sense as an idea?
In my experience, WebAssign is very stingy about that.
It's a little bit picky about certain things, so it's just good. And if you think that you're getting it right, you can send me a message and say, I think I'm doing the right thing, am I close? And I can tell if you're close and it's a rounding error. Like, that's easier for me to check in my answer. Like, when you send me a message, like, ask your teacher, I can see what you did and I can see the answer key. So it's super easy for me to say, oh yeah, you're off by just a little bit, try not rounding off. Like, try rounding these answers like with more decimals in them before you compute your answer. But it does definitely have tolerance because I could see an answer key in it counting it right. So there is some tolerance unless they specify. Okay. Righty. Okay. This one, we'll do the last two because they won't take very long, and the next lesson is the same thing, so we will take a break. But if an equation to the tangent line to this curve is this, find the function at 1 and the derivative at 1. This is a little bit of a puzzle. Okay, so you have some curve, and at the point 1, what is this? How can I tell that the curve has to be going down?
Negative.
The slope is negative, so it has to be going down. Does that make sense? Okay, so observation number 1 is that the tangent line and curve, there's a V there, intersect at A equals 1. Does that make sense? The tangent line and the curve and the tangent line go through the same point. So how could you find the y value on the curve then? Plug in 1. So f of 1 is the same thing as negative 7 times 1 plus 2. So f of 1 is negative 5. You don't actually know what the function f is, right? As in, f isn't the line. But the fact is that at that point, because it's a tangent line, plugging 1 into the function is the same as plugging 1 into the tangent line at that place. Okay, observation number 2. What is the meaning of f prime of 1? Slope of tan line at A equals 1. So what does f prime of 1 have to be then? What is your tangent line at A equals 1? Nope, your tangent line is negative 7x plus 2. What is the slope of your tangent line? So f prime of 1 is negative 7. You see what I'm saying? The plus 2 came from knowing a specific point, which you don't know. But the thing is, f prime of 1 is asking what is the slope of the tangent line. Well, that's your tangent line. The slope is negative 7. Okay, awesome. And then the last question before 5-minute break is the next one. Okay, so I think these are good because they make you think. So sketch the graph of a function of f who is continuous on the domain negative 5 to 5, which means it doesn't go outside negative 5 to 5, where f of 0 is 1, f prime of 0 is 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Alrighty. So f of 0 being 1 means what happens at 0. Your y value is 1. Okay. Now, since f prime, the slope of the tangent line, is equal to 1, that means the slope is 1-ish near 0. You see what I mean? The tangent line is close to the function, so the slope is kind of 1-ish. So it's doing something where it's kind of like, 1-ish, 1 rise over 1 run. What happens? So it means it has to go up, right? What happens at negative 2 to the slope? 0. What does a 0 slope look like? Straight horizontal straight line, right? So you have to go down, and maybe you're going to go down to here, but the slope has to be 0-ish at that point. It doesn't necessarily have to be on the x-axis. It could be, but so we weren't told that f of negative 2 was 0. But it wouldn't be wrong to put it there. Okay. And then the limit as x goes to negative 5 from the positive side is negative infinity, which means you have a vertical asymptote over here. And what is the function approach as it approaches negative 5, or positive 5, sorry? It goes to 4. Does that make sense? So you're going to have an open circle there. Why does that have to be an open circle, and why is it not filled in? Because of this part. Okay. So your function could do something like this. It could go down to that point, curve around. It could go up and then go down, but the slope has to be 0-ish there. It could do that. And then it has to go up to that point, but how it does it specifically is up to you. But you can't go outside -5 to 5. You've got to have this one right point. The slope is 1-ish. Get a color. Slope is 1-ish right there. Slope is 0 right there. Function goes down to -infinity and approaches 4 as you come at 5 from the left. Those are tricky, and I kind of like assigning them in WebAssign because you have to read the conditions and figure out which one works, which I think is a better way to do it than having to figure it all out yourself. Okay, so we'll stop and take a break for a little bit. Let's take 5.